Hey, Airflow community, we've got exciting news. The annual Apache Airflow survey is live. In just 7 minutes, you can help shape the future of Airflow and grab a free Airflow 3 Fundamentals or DAG authoring certification worth $150 each. Plus, you can enter to win an exclusive workshop with Mark Lamberti. Don't miss out. The survey link is in the show notes and closes November 21st. Hi, everyone. Welcome to the Data Flowcast. I'm your host, Kenton Danis, and today I'm joined by Alex Iannicelli, who is an open source software engineer at Overture Maps Foundation, and Daniel Smith, who is a senior solutions architect at Wherobots. How are you both doing?
Great. How are you?
Yeah, doing well.
I'm doing great. Thank you.
Okay. Well, for our listeners, for today's podcast, we're going to discuss using Airflow to manage geospatial data. I think this is a super interesting topic. I had a very tiny bit of experience working with geospatial data in a previous life many, many years ago and have not touched it since. So this was long before Airflow, I think, was even a thing. So I'm excited to dive into it with you both. But before we do that, I want to start with some background. So maybe you can both tell me about what you do and what your companies do.
Yeah, definitely. My name is Daniel Smith. I am a senior solutions architect at Wherobots. I've been in the geospatial industry for 20 or 25 years now. But Wherobots provides a SaaS platform for running Apache Sedona. And so in the same way that PostGIS brings spatial functionality to the widely used Postgres database, Apache Sedona brings spatial functionality to the widely used Apache Spark system. And so Wherobots is actually run and created by the original authors and the maintainers of the Apache Sedona project. And so we have additional optimizations that run on top of it that kind of take it from 1 to 11, if you will. As well as some additional value add products on top of that.
Yeah, that's great. Well, we at Astronomer, we love open source companies or open source focused companies, of course. So cool to see another Apache Software Foundation project. Getting a bump up to 11, as you said.
There we go.
I love that. And Alex, what about you?
I'm Alex Iannicelli. I'm principal software engineer at Overture Maps Foundation. I've been in the GIS industry for only about 5 years. Before that, lots of different, cloud computing and storage and networking protocols and things like that. At Overture Maps Foundation, we're using open data. We get open data from multiple different sources, and we need to conflate them all together, merge them all together for our monthly release. That is completely free to use for anyone on the internet.
Yeah, very cool. And how do Wherobots and Overture Maps Foundation work together?
So at Overture Maps Foundation, we use the Spark processing for our spatial joins and spatial merging of all this data. And we were using just AWS Glue and Azure Databricks for that processing, and Wherobots came along and said they'd like to be part of that, and we worked together with them to create we have a agnostic Spark class, so that we can kind of point using Azure's parameter, one parameter in Airflow, using an Airflow parameter, we can choose what platform we run all of our Spark processing on, and Wherobots is one of our default ones that we use for a lot of our pipelines.
Yeah, I think that relationship goes back to, I think, the middle of 2024. And originally, I think that we just kind of wanted to see where Wherobots can fit into this project. And initially, we started to do some benchmarking and some testing between the default settings and the settings that you guys were using in Databricks and in EMR, and running those against, Wherobots. I think, whether Alex and Overture runs their pipelines wherever, they're using Sedona at the core, right? These are Sedona pipelines. And so just, doing a pure lift and shift, right? We just took the main business logic from doing some of this conflation, right? Taking OSM buildings and then other machine learning and other generated building data sets specifically for this pipeline, and just replicated that within the platform, and we're able to see some nice performance gains, which drove down the cost and increased performance overall. And so I think from there, that's when we started to really kind of team up, like with Alex's team and the other folks at Overture and the other folks at Wherobots, to migrate these workflows, right? And rewrite them so that they can be run within Wherobots using our Airflow operator. And so when Alex talks about the agnostic class, from our perspective, what we've helped with there is, being able to point the pipeline and run it, like Alex said, with only one parameter change using the Wherobots run operator. And so it's this open source operator that we maintain specifically for running the geospatial jobs within the Wherobots environment. And so we actually have two different operators that we run. We have a basic SQL operator, which returns, just as you would expect, it returns the results from a specific SQL query. And we have a larger runs operator, which is what we use with Overture. And this allows a much larger process or script to be automated. And so I think that those are the ways that we really kind of work together. And so we've got a couple of guys that work with Alex directly to kind of help implement some of these more technical things.
Okay, very cool. And maybe just zooming out a little bit, talk to me a little bit about where Airflow generally fits in with the Wherobots platform. And you mentioned that's kind of a managed or adding additional features on top of Apache Sedona. And so how do you think those two tools most effectively work together?
Yeah, I think that the amount of geospatial data being created 20 years ago was smaller than it is now, obviously. And it was less frequent, right? You had different processes and different techniques and tasks that would generate this data that was either pushed out, daily or weekly or whatever. With the proliferation of like mobile devices and cheap IoT devices and the sensor networks that we have out, we have, terabytes and petabytes of data coming in. So where Airflow and Wherobots kind of mesh is in that processing, right? We have our interactive workloads. It's a Jupyter notebook, so you can come in and kind of define your process and work out, what you want to do, how that business logic needs to transform or load or analyze that data. And typically what our customers do will take that work and then automate it with Airflow, right? Like that data comes in every day, sometimes every hour, sometimes every minute, frankly. And that's really where Wherobots and Airflow kind of start to mesh, is in that reoccurring constant processing of this stream of data that is constantly being generated by our cell phones, by our connected devices, by assets and tractors in the field, by delivery vans, like all of this stuff, DoorDash, Uber, like everybody has cell phones, everybody is collecting GPS data, whether they like it or not, like that's being fed somewhere, and that data needs to be processed. And that's kind of where Wherobots and Airflow and the Airflow operator kind of start to shine.
Yeah, and at Overture Maps Foundation, I mean, so we have a few different levels of data processing. I mean, the very first one is just getting the open data from the vendor and bringing it into our environment and converting it to our schema. And that's one set of pipelines. And then we have a separate set of pipelines that for each theme, we've got a number of different themes, like buildings is a theme, places, transportation, those types of themes. Each theme has a pipeline that takes the data, the multiple different open data sets, and converges them into the data set that we will present for our theme. And then finally, and that's a set of different pipelines. And then we have one big pipeline at the end that takes each one of those themes and processes that for a data set that can be released. And that is every month, but then a lot of those themes are being run multiple times a month, just to make sure. And anytime we make a change, we're doing testing, things like that. So, and Airflow makes it really easy to see the progress of all the themes, pipelines, and see where we have issues and be able to drill into the logs and be able to debug things too.
Yeah, got it. And so to vastly oversimplify what you've just said, so Wherobots built on top of, Sedona is the processing engine that's specifically built for geospatial data, and you're using Airflow as the orchestrator, which
Absolutely.
totally makes sense. I love that. What, if any, are there, I guess, what, if any, special considerations do you think are required of an orchestrator like Airflow in this case that are being used for geospatial pipelines?
I mean, I would say I look at each of the tasks that the Airflow pipeline or DAG is executing, just as a job that needs to be done, and it takes a certain amount of time. I personally love how Airflow allows me to, visually see what's running, click into it, see the logs, and be able to watch the progress of whatever that thing is. I mean, so when we're working with Wherobots has all their logs coming from Spark, feeding into that log, and we're able to see whether things are going off the rails or not, because sometimes they do, and we don't want to spend extra, compute resources when things are going bad. So I guess that's not very specific to GIS, but like we have these massive data loads that we have to process the whole entire world of features, and so they take hours at times. And so being able to just see that this is in progress and be able to drill into it easily using a GUI has been great.
Yeah, and I think that, kind of dovetailing into the scale of the spatial data, the scale that Airflow can scale to is really the benefit here, right? Like we have so much data being processed, and Airflow is not a bottleneck for orchestration, right? It will, kick these tasks off. It doesn't necessarily have to. It's not, memory bound from when you use our operator, right? You're deploying and running this code within our processing engine. And so I think for me, like the specialness of Airflow in this is the fact that it just scales, and it scales in processing time, and it scales with the size of our data and the number of processes that we have. And it bears mentioning that, for folks that aren't familiar with Overture Maps Foundation, like they have a gigantic amount of data. I mean, we're talking about global building footprints. I think last time I checked, this is in 2.6 to 3 billion polygon range.
Those are the ones that we release. So
Those are the ones that we
processing
release.
way more than that, and then filtering out. Yeah.
Right. And that process includes, I think, 5 or 6 different building footprints data sources. And that's just one of their themes, right? They support, unique POIs and places data sets. They have, administrative boundaries and natural features, water bodies, parks, all kinds of stuff that comes in. And I think that it's an amazing group that has decided to come together to do this, right? Like it's all built on top of, like, I think OSM, like the OpenStreetMap data, it serves as the base layer for a lot of these. And that data in and of itself is huge, right?
Mm-hmm.
And so being able to process all of that, like Alex said, with 7, 10 different sources coming in, and not having the orchestration tool be the bottleneck, right? And with Wherobots, the processing is no longer the bottleneck. It allows, for faster iteration. It allows for, like Alex said, observability into the process, and kind of just keeps the boat moving. After spending a lot of time in this area, like, we'd spend time manually dividing up the data, like Alex processes, by country or by county or by state, right? And just having to manage that code, right, is onerous, and it's time consuming. And so writing those tools to orchestrate parsing and to writing those tools in code that orchestrates subsetting down is kind of removed from the process. Like we don't have to manage that part anymore, and we don't have to worry about the processing time or the amount of memory that has to go in. So like these two barriers and these two things that, had to be in the front of an engineer like Alex's mind, are kind of removed, and it allows him to focus on the business logic, focus on bringing in new data sets, focus on all these other things that are more creative outlets for his skills than, orchestrating multi-threading in Python, right? Like, or orchestrating multi-processing in Python, whatever the case may be. It frees up I mean, I speak for myself. I can't speak for you directly, Alex, but it frees me up to do the things that I enjoy more. Which I think is really kind of the goal with orchestration tools. And yeah.
Yeah, absolutely. And we talk about orchestrating the pipelines through Airflow, and then all of a sudden we go, well, what else can we orchestrate using Airflow that we do often? And we end up creating all these other pipelines that aren't exactly part of the normal release pipeline, but I can push button, do this, do that, all these different things, all these different tasks that we do often. It's really been great.
And the other things I think I really like about Airflow, just some of the fun things that I've used are like the circuit breaker operator, right? There's these really cool, like clever little tricks and things that you can do with Airflow that make your processing easier. And they're kind of fun, honestly. Like it was a little intimidating at first, kind of getting into it just because it's something so different than writing like normal Python code. But it's kind of enjoyable. Mm-hmm.
And working with the dependencies, like setting up dependencies in Airflow tags have been, when you set them up properly, and then if you happen to have to run just this one task and to have it flow through and only run everything else that's dependent on it, but just those things, not the other things. That's been very cool to see, because some of these tasks that we have, like I said, take hours to do. And like very often we have, like Daniel said, we have multiple, just thinking about the buildings, we have like 7 different sources, and OSM is updated the most frequent. And it happens to be kind of at the top of our priority. And so if that has to be updated, we can go in and just say, run that one task, update the whole thing, and everything downstream of that will run. But the other sources, they don't have to be reconverted because they haven't changed. And so a lot of that work is simplified with the dependencies. It's been great.
Yeah, absolutely. I think you've done a very good job of describing kind of the feature richness of something like Airflow, which, to your point, can be, I think there's a lot of unknown stuff that people don't even realize is in there. But it is, does cover almost all of the use cases that you would need for orchestration. I think to your point, if you implement it correctly, can scale quite effectively, especially if you're doing so, with a separate processing engine. I think one of the questions that my team gets a lot is, can you process data within Airflow? And it's always like, yeah. Sort of, to some extent.
But try not to.
Certainly not when you're talking about like the scale of data that you're discussing here with geospatial data. You would not want to do that on your Airflow worker. So yeah, I think using it in combination with a tool like Wherobots is really cool. And I do want to kind of circle back to, we talked a little bit about the Wherobots operators, but just speaking about, like the feature richness of Airflow, one of the things that I think is really cool about the open source project is that so many people have committed, providers or made available, even if they're not within the project themselves. In fact, most of them are not, ways of interacting with external tools that make it a lot easier. And it sounds like, so you have done this for Wherobots with your operators. Maybe just tell me, one more time a little bit about kind of what those look like, and are they open source, and how does a user interact with those?
Yeah, definitely. So there's two different operators that we support. The more basic operator is the SQL operator. And so the parameters that it takes are super straightforward, right? You take an API key and you've got a connection string, right? And that's how you make a connection to our cloud offering. We actually do this with the free version of Wherobots. So we have a community version that you can sign up for. It gets you access to smaller runtimes. It's available on the marketplace. You can go to our website and check it out too. The more comprehensive operator is the runs operator. And this really encapsulates our entire runs API in an easy to use Airflow operator, right? So the REST API has all of the get, put, like all of those fine tune in points that allow you to orchestrate the job manually. But we've packaged that up and it's directly available on GitHub. And so for that, I mean, it's a really basic install, right? You just have it as part of your requirements file, whether you're using a managed Airflow instance or you're, rolling your own. And then when you rebuild, like that operator is available to you. And so I think that some of the good parts about it is that you can use all of your, command line arguments. And so if your process takes, inputs for say an AOI, right? Like an area of interest, a polygon, that can be coded and sent through if it just has different parameters. Like we actually maintain a mirror of the Overture Maps Foundation data within our spatial catalog within Wherobots. And so I actually run our mirror task, as just this, right? And so it just uses the Wherobots operator. And what it really does is it calls a Python script or like a jar file that's either in managed storage on our end or in your guys' S3 buckets or a user's S3 buckets if it's attached. And then it kind of calls that script within the environment. And you can specify your size of your environment. Like I was saying, that there's different size environments that you can use depending on your workload, which is another great part about, using Airflow and using the DAGs and the tasks. Like if you have a task that imports data, right? It ingests data, and the first task is to migrate that data. You can get a rough estimate of that data size, and then using like the XCOM, communicate back to the Whereabouts operator and kind of dynamically size the runtime selection that you have there, which is a really nice feature of being able to kind of dovetail these processes together. Those are nice. We also support like all of your individual dependencies. And so you can specify either as part of the runtime or part of the dependencies as the command, the parameter within the Whereabouts operator to say, we need these different packages, please install those first before you start the actual environment. So they're all available if you have additional dependencies. And so it's pretty well, feature complete from what I've seen. But it really didn't start that way, to be honest with you. Like I think when we first started working with Alex and the operator, like we didn't have some of these pieces in here. Was a really great learning experience, iterating with Alex and the Overture Maps team to extend and expand, our operator for a real world use case. It was a really good opportunity for us to kind of finish that build. And like I said, it's completely open source. You can go onto GitHub and look at both operators there. And they're available on PyPy too. So when you go to install, like that's really just how you do it. So it's available on PyPy. That's how you get to it with your requirements file for installing on the actual Airflow instance.
Yeah, great. Well, we'll definitely include links to the GitHub repo and stuff in the show notes. That sounds like a really cool partnership. And like I said, I always think one of the best things about Airflow is having operators available so you don't have to figure out how to write all that code yourself. It sounds like, especially in this case, that would save you quite a lot of time. Yeah, very cool. Well, speaking of Airflow features and providers and such, I always like to end with a standard final question for folks, and that is, what would you most like to see from the Airflow project in the near future?
This is one of those things that I don't know whether it exists or not. I may be missing this, but I'd love to see an easy way for DAGs to trigger DAGs. So when a full pipeline is finished based on some output, trigger another DAG to execute.
And is that in like a different way than data sets, or now they're called assets in Airflow 3, in a different way than those would work? Or
I don't know. We're on Airflow 2, aren't we?
Yeah.
Yeah. So we're not in Airflow 3.
Yeah, I mean, as long as they're on, I think it was 2.4 that data sets were introduced. So
Okay.
you should be able to use feature design for exactly that, where you would indicate, a task, and it could be the last task in a DAG that updates data set or asset. I'm using quotes because Airflow doesn't actually have any awareness of what that underlying thing might be. That's just the name. But then you can have that as the schedule for a DAG, so it runs whenever that is updated.
Cool. Yeah. All right. One other little thing. In the GUI, being able to group things by like directories or groups, being able to group DAGs by those, that'd be cool. But just visually, it's just nice.
Yeah, that's definitely a frequent request. I have seen in the very early stages 3.1, which should come out by the time this is released, I think it will already be out. But like mid-September-ish timeframe, there is at least now the ability to favorite DAGs. So you can pin them like in the UI, which at least for the ones that you need to look at like every day is nice. But yeah, being able to group them or organize them in a different way, I think is something a lot of people want.
I think I don't know. I don't think I have a lot of requests right now. I'll go back to our engineers and see what they say. Frankly, I'm a geospatial guy at heart, so any amount of spatial awareness that could be built in, like it could even just be a map somewhere. Like just embed a map anywhere in there, and I'll be a happy camper.
Yeah, there you
Put
go.
any map there.
Maps are great. Yeah,
Maps are great.
I love that suggestion. Okay, cool. Well, thank you for going through all of that. This has been really interesting. What is the best way for folks to get in touch with you?
Daniel, go ahead.
Yeah, it's a super difficult email. It's just daniel@wherobots.com. You can just hit me up there at any time, or support@wherobots.com. Both of those will come to me. Or you can jump onto our website, like I said, and have a support request if you want to do a demo or just see what Wherobots is all about. Those are going to be the best ways to reach out and kind of do that. And like I said, jump onto the marketplace, sign up for a free tier account, jump onto our website, sign up for a free tier account. There's a bunch of data there for you to work with, inbuilt examples and notebooks. It should be pretty easy to get started. And if you have any issues, then I'll go talk to my boss about it. So you can go from there.
Cool. Great.
Yeah, and Overture Maps is overturemaps.org. And you can get the data that's released every month for free. So check it out. Go look at the GitHub repos that we have that are public, and if you have issues, post them there. We do listen. And you can reach me at alex@overturemaps.org.
Okay, great. Super easy. We'll throw all of those links in for folks who want to access them. Well, thank you both again for joining me today. This has been really great.
Thanks, guys.
Always a place. Thank you.